So we're going to be making solutions for a couple different labs, and so we need to kind of go over uh, what equipment you're going to be using and also some of the math associated with it. So this is a section talking about making dilutions. So there are going to be two pieces of equipment that you're going to be using to make up the solutions. One is called a volumetric pipette. That's the one here on the left. And a volumetric flask is the one here on the right. So the volumetric flask is used as a container for any solution to be an exact volume. So this piece of glassware is made to contain a certain volume. And what you will see is always a line on the neck of a volumetric flask that gives you exactly where that volume is going to be. So in this particular picture, they call it a calibration mark. So if you fill up a liquid up to that level, that's going to be exactly 100 milliliters or whatever the size of the volumetric flask happens to give you. That's very important if you are putting a solid into there and then you're adding water because the solid will add some volume to it. So that will compensate for that. If you have a liquid and you need to put it into a new container, you could use a pipette. Now, please note the spelling is different depending upon just the application or the resource you're using. So a pipette is going to be a way to what we call dispense the liquid. So this is going to be used to put into a flask. It will also have a little line on it that shows you what that volume is. So this picture is showing you is 10 milliliters. So if you put this into a container and suck up the volume to that line, bottom of the meniscus, you essentially have 10 milliliters that you could then dispense into a flask or into another container. So these are going to be two pieces of equipment that I'm going to have you use in the lab and also describing some of these calculations going forward. So we are going to do some calculations going from what we call a concentrated solution to a dilute solution. And you can go the other way, but then you would be removing water. And that's a little harder to do. So usually you go from concentrated to dilute. So let's say I have a dark blue concentrated solution. And a dilute would be then more of a light blue because I have added water to it. Okay, so we're going to use molarity, and we're going to use a very important equation called M1V1 is equal to M2V2. And maybe you've seen this before. Sometimes we use it for acid-base titration. Again, if you don't remember this or have any idea what I'm talking about, don't worry about it. But M1V1 is molarity times volume is equal to molarity times volume. So molarity 1 is going to be, so this side is going to be the concentrated side. This is going to be the dilute side. It really doesn't matter how you set it up, but just to kind of keep it straight. So this will be the dark blue going to the lighter blue. So the concentrated solution, what are you starting with? What is the volume you need of the concentrated solution? Usually that's going to be your X. That's going to be your unknown that you don't know and you're trying to find out. The new concentration is going to be on the right-hand side. That's the dilute portion. I need to make up a 0.5 solution from a 1 molar solution. So again, the new concentration usually are given. And the volume we want to make. Okay, I have 2 classes of advanced chem, so I need so many milliliters to kind of make sure that it's done. Do note that for this calculation, molarity is of course moles over liters. But do note that volume, you can do it in milliliters or in liters. It does not matter because if you multiply on both sides with either one of them, it will be perfectly fine. So to try this out, we're going to do a problem here. How would you make 500 mils of a 1.2 molar sodium chloride solution from a 5 molar stock solution? And again, the word stock has to do with the fact that I am getting it from the stock room or from some other source. But do note that the 5 molar is a bigger number than the 1.2 molar. So that's going to be always where you start looking. So this is going to be your concentrated solution. This is your dilute, okay? So if you're setting up M1V1 is equal to M2V2, my concentrated solution is 5 molar. I want to know what the volume is going to be to put into that volumetric flask. I know I want a 1.2 molar solution and I need a total of 500 mils. Again, Please note that you could use milliliters. You don't need to spend the time converting it to liters and then making a mistake. So mathematically, these are easy calculations. You get about 62.5 milliliters. So that's never the issue with these calculations. What is always going to be asked of you is, what is that of? Okay, the 62.5 milliliters, what is that? Well, that happens to be your stock that you need. That's the 5 molar stock of the sodium chloride solution. Well, what are you going to do with that? What kind of equipment do you need to use? So you're going to use a volumetric pipette, okay, to dispense exactly 62.5 milliliters. Now, do note that you probably are like 62.5 milliliters. Let's assume that we have magical volumetric pipettes, and so that we could have any volume that we want, okay? So we're going to take that volume, we're going to dispense it into a volumetric flask, and the volumetric flask is going to be 500 milliliters, okay? Now, what was not kind of described to you is, well, once I put that 62.5 milliliters in there, what else do I need to do to it? Well, I need to add water to complete the dilution, okay? Now, I want you to be more specific. I want you to say you add water to the line, okay? So going back to what we just talked about, so you're going to add water until you hit the top of, the meniscus is going to hit the bottom of that calibration mark, okay? You're going to add water to the line. And then I also want you to say that we're going to mix it, okay? So that we get all of it dissolved, mixed up together. So those are going to be the steps that we include in order to complete making a solution. Yes, the math is going to be there, but I do want you to mention I have a volumetric pipette, I dispense into volumetric flask, and I add water to the line and mix.